So today we're going to talk a little bit more about the fundamental theorem of calculus, and we're going to apply it to what I call initial value problems. So the fundamental theorem can be used in a lot of ways, but one of the most important ways is that if you have to evaluate a definite integral, you take an antiderivative of the inside, plug in the top, plug in the bottom, and subtract. Now, what you can do with this is I could add f of a over to the other side and say f of b equals f of a plus the integral from a to b of f of x, dx. Now, how does that help us? Let me show you. Find f of 5 if you know that f of 3 is 2 and f prime of x is e to the x over 2. Well, how does that relate to what's going on up here? Well, here's how it relates. It relates because capital F is an antiderivative of lowercase f. Well, isn't f an antiderivative of f prime? Yes, it is. So you can take the fundamental theorem of calculus, instead of saying, well, f is an antiderivative of lowercase f, you can say that lowercase f is the derivative of f and use it that way. So basically, long story short, what I can do with it is this. I can say if I want to know f of 5 would be f of 3 plus the integral from 3 to 5 of e to the x over 2. F of 5 equals f of 3 plus the integral from 3 to 5 of e to the x over 2 dx. That's exactly what we have right here. We have the derivative right here. We have an initial value of the function right here. And we have the ending value of a function right there. I'm going from 3 to 5. From 3 to 5, everything matches up. And now it says you can use your calculator. So you're going to want to take out your calculator. I'm going to let mine load up, and we will answer this question. So give me a second to pause so you don't have... All right, so here's my calculator. So if I want to evaluate this, all I have to do is do 2 plus the integral from 3 to 5 of e to the x over 2 dx. And again, I got this 2 from the fact that f of 3 is 2. And so I'm just going to plug that into the calculator. I'm going to write 2 plus math 9, the integral from 3 to 5 of e to the x over 2 dx. Ta-da! And I get 17.4016, so 17.4016. I know I don't need to go that far, I just felt like it. And there you go. Here's why it's called an initial value problem. I know f of 3 is 2, and I know the derivative. I have an initial value of a function, and I know its rate of change. I want the ending value of the function on a specific interval. Okay? So now we're going to do it a different way. If find f of 1, if you know that f of 7 is negative 4, and the derivative of f is that. Okay, fine. Well, the integral of f prime from 1 to 7 would be f of 7 minus f of 1. So if I want f of 1, I need to do f of 7 minus the integral from 1 to 7 of f prime dx. So I really use that same rule. Here's the fundamental theorem of calculus. The integral of f prime would be lowercase f of 7 minus lowercase f of 1. And I'm looking to solve for f of 1, so I swung that over to the left, swung the integral over to the right, and got this. So if I want to find f of 1, I'm just going to plug that right into the calculator. And they told me f of 7 is negative 4. So negative 4 minus the integral from 1 to 7 of ln x squared plus 1, and parentheses, get over here to the dx. Ta-da! Negative 19.978. Ta-da! All right, find f of 2. If you know f of 1 is 6 and f prime is that. No calculator this time. Well, that's not going to change my process. F of 2 is f of 1 plus the integral from 1 to 2 of f prime dx. So now I just need to evaluate f prime. Okay, well, not evaluate f prime, evaluate the integral. All right, well, fine, I can do that. So f of 1 was 6. And to evaluate this integral, I need to take the antiderivative. So I'm going to add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. And minus x. This is a definite integral, so I don't need the plus c. And I'm going to evaluate that from 1 to 2. And then that's going to be 6 plus, let's see, 8 plus 8 minus 2 minus 1 plus 2 minus 1, which, trust me on this, after you go through everything and get an answer, you end up with an answer of 18. So, there you go. 18. F of 2 is 18 if the derivative is that. Well, there's another way to go about this. And the other way to go about that is this. I know f prime. F prime is 3x squared plus 4x minus 1. Therefore, f would be the general antiderivative of f prime. Well, the general antiderivative means find the antiderivative and stick a plus c at the end. So if I were to take the antiderivative here, I'd add 1 to the power, divide by the new power, add a plus c. Here's my general form for f, but I know that f has to have a value where f of 1 is 6, so f of 1 needs to be 1 plus 2 minus 1 plus c, and that has to equal 6. So now I can solve for c. 3 minus 1 is 2, 2 plus c is 6, so c is 4. So f of x is x cubed plus 2x squared minus x plus 4. Again, c went in for c. Therefore, f of 2 would be 8 plus 8 minus 2 plus 4, which is 18. Two different ways to get the same answer. All right. Now, the next one gets kind of tricky, so what I'm going to do is let's save that for class when we come in tomorrow. So flip over to the back. Now we're going to do this and apply it to rectilinear motion. I am actually going to go through the second one with you and then have you try the other ones and then just come back and check your answers. That should simplify things for us a bit. Let me see how my timing is going. Where's my timer? 7:50. Not bad. All right, so I want you to take a second, read example 6 here. We want to find the position function if we know its acceleration is that, and its initial velocity is 12, and initial position is 18. And remember, position is s, velocity is the derivative of s, acceleration is the second derivative of s, and you can call them v and a, it's fine. So if I know acceleration, a of t, is 5 minus 6t, then I know that the velocity is the antiderivative of this. All right, so the antiderivative of 5 minus 6t is going to be 5t minus 3t squared plus c. Initial velocity is 12. The word initial in your vocabulary from now on needs to mean t equals 0. So if it ever says initial velocity, that means v of 0 is supposed to be 12. So v of 0 is going to be 5 times 0 minus 3 times 0 plus c equals 12. So c is 12. That makes the velocity function 5t minus 3t squared plus 12. So then my position function is the antiderivative of that, which is going to be 5 halves t squared minus t cubed plus 12t plus c. Initial position is 18. That means s of 0 is 18. So 0, 0, 0 plus c is 18. So c is 18. So my position function is 5 halves t squared minus t cubed plus 12t plus 18. All right. And that's what you got. And it says find the position function. That's the position function. We just leave it like that. All right, I want you to take a second, pause the video, and then come back and we'll do example 5 together, and we'll save example 7 for when you come into class tomorrow, all right? So just look at number 5 and try and do 5 on your own. Come back. It's a nice, easy one. Pause. I hope you paused. Okay, now you're back. Find the position if its velocity is given by this. So if I just want position from velocity, I just have to go backward once. So v of t is 68 minus 20t. So s of t, the antiderivative, is 68t minus 10t squared plus c. Initial position is 5. So s of 0, which is 0 minus 0 plus c, is 5. So c is 5, making my position function s of t equals 68t minus 10t squared plus 5. All right. Come to class ready to work tomorrow, and I will see you guys then. Bye-bye.